Let's start the class. Are you able to see my screen?
Yes, ma'am.
Okay. Okay. Let's get on to the session. So, once again, let me see if I started recording. Started recording as well. So, we'll begin the week 10 live interactive session. Okay. So, as usual, we'll have a recap of the lectures of the week 10. Okay. So this week also the concept was based on polymer processing and recycling techniques. So lecture 70 was on polymer processing. Again, it was on uses. So different shaping operations and then extrusion, dyes, and then there was a discussion on dye spelling as well, right? Even though the diameter of the die is of particular shape, the product coming out due to different mechanisms, it might not have the exact diameter or shape of the die, right? And then stretching was discussed, and then rolling, blowing, and then blow molding process was discussed in detail, and time scales for polymer processing operation like cycle time and then production rate for different polymer processing were discussed. And then mixing in polymeric system, where the mechanism of mixing, here in polymeric systems you might not have turbulent kind of mixing. It is more of a laminar kind of mixing, right?
Yes,
Laminar
ma'am.
kind of a mixing, yes. And then there is a dispersion mixing also, for particulates and fillers and all, right? And then mixing operations were discussed, right? And then the next lecture was on flow simulations. Again, this was on uses. So modeling of polymer processing, which involves a multi-scale phenomena. So continuum approach was described, and then molecular approach was described, right? And then
Yes,
where transport phenomena, it involved different approaches like mass balance, energy balance, and then momentum balance was discussed. And then molecular dynamics, the concept was discussed. And what is the purpose and need of modeling, to design the processing operation and to have optimized processing conditions, right? And what would be the final shape and all, in order to predetermine these things, the modeling and simulation becomes mandatory, or it becomes very essential part of the polymer processing, right? And mass balance, where conservation of mass, the expression for conservation of mass was discussed. And then conservation of linear momentum, which is nothing but the Newton's second law of motion, right? And conservation of energy was discussed. And then different polymer software, sorry, simulation softwares that are used, right? Like FEM, and different models like Fini model, right? Finitely extensible, non-linear elastic model and all were discussed, right? You are able to recollect?
yes, ma'am.
Yeah, fine. And then lecture 72 was on processing for recycling, so which was on sustainability aspect of polymers, right? So different recycling methods, what is the primary recycling, and then what is involved in secondary recycling, and uh, what is it that comes under recovery and conversion, and what is a target in national resource efficiency policies, like 100% recycling of PET, right? And 75% reuse of other plastics as well, and all were targets, right, by 2025 or 2030, right? And then what are the operations that are needed for needed before recycling the polymer, because it comes as a kind of multiple things mixed together, so you have to sort out, size it, sieve it, right? Different operations are carried out, right, based on the material size, etc., right? And then pre-processing and what are the processing conditions for recycling, and then what are the property change due to recycling, even how many properties, how significantly the property change, like molecular weight changes drastically, your mechanical behavior changes drastically, even if it is going to be a single material, single polymer. So the complexity would multiply to a larger extent when it is a polymer blend or a complex polymer system, right? And then lecture 73 was on recycle, up down cycling. This was also on sustainability. So how are the waste handled in India? What are the major challenges, especially related to the mechanical recycling or upcycling? And then additional challenges, especially related to the polymer processing network, because of it complex transport phenomena, rheological behavior, right? These points were all put forth. And then what are the upcycling processes that can be thought of, like mechanical upcycling, chemical upcycling, and then even biological upcycling, where polymer is first depolymerized and then it is again polymerized through a biological system, right? And then design for recycled polymer materials. And then what are the different upcycling methods of polypropylene with LDPE, so that you have some synergistic behavior, benefits, etc., were all discussed, right? And then lecture 74 was again on recycle up down cycling. So here biocomposites, where natural fibers like jute or cellulose or something can be combined with the recycled polymers to form composites. And then there was a discussion on twin screw extruder and polymerization and molding, where reaction injection molding was discussed, and then resin transfer molding process was discussed. So where in case of reaction injection molding, the polymerization is very instantaneous, right? That is why during the molding operation, the reaction happens so fast that the molding operation is also carried out simultaneously. Whereas in resin transfer molding, the kinetics is slower and it is used for bulk production, like in aerospace or large size materials and all, right? And then how biocomposite sandwich structure can be made, where this soy protein based composite was also discussed, right?
Yes,
Hello.
ma'am.
Yeah. Just say if you're there or not, because when I'm going through the slides, I may not be able to see whether you people are there or not, okay? Or my connection is got cut or anything, okay? And then lecture 75 was on flow behavior, rheology. So this was on concepts. So polymeric fluid flow, and then polymeric fluids as products, like your finished products, like your in food applications, like your jams, sauces, jellies, or during processing polymers and composites, right? Your melt solution, and how is the macromolecular inflow, like different classifications, like your polymer melts, polymer solutions, right? And gels. And in again in gels you have different type of cross-linked gels. One is a physical cross-linking, the other one is a chemical cross-linking. These things were discussed. And then mechanisms that affect the flow of macromolecular systems, right? Like molecular intramolecular and intermolecular interactions, entanglement, right? And then the in combination with solvent, all these things affect the flow behavior of macromolecular systems, right? And then
Yes, ma'am.
non-Newtonian fluids were discussed. And uh, different flow scenarios, what is the response of the macromolecules, like steady state simple geometry, unsteady state complex geometry, right? And even in non-Newtonian fluids, how is the viscous behavior and viscoelastic behavior? In viscoelastic behavior, again this elasticity, how it plays a role, right? All these things were brought into picture. in flow behavior rheology. Okay. The next was on cross-linking. Again, what are the different cross-linkers for polymeric systems, for step growth polymerization and for chain growth polymerization, and how functionality plays a role? What is the extent of reaction for cross-linking, and how is rubber cross-linking affected? What is the cure time, and how do you measure the extent of cross-linking through your torque value? Right, there was a plot with torque versus time, right? With which you can find whether it is properly cross-linked, or is it overcued, or it is degraded, right? And then there was a discussion on oscillating disc rheometer and moving die rheometer, which are used during the process, trade test during rubber for rubber cross-linking and all were discussed. And then cross-linking and gelation, right? How do you find the gel point, and how the behavior changes, like your mechanical behavior, your storage modulus and your loss modulus changes drastically after the gel point, right? As a sol and as a gel, how it varies, were all discussed in lecture 76. And the final lecture of the week was on conversion of polymers. This was on sustainability. So conversion and combustion of polymeric materials, where chemical recycling was discussed. And then factor that affects conversion, like your rate of conversion, which is affected by your pH, or and even monomers affect the rate of conversion, right? Solvents, what are the different solvents, like your ionic solvents, supercritical fluid that can be used. And then role of absorption and diffusion reaction, like your surface reaction and your bulk reaction, how it really affects, and all were all discussed. And then chemolysis of PET, so converting PET into its monomer or conversion into feedstock, was all discussed. And then combustion and incineration of polymeric materials, where the primary objective of combustion and incineration is to is removal of waste, but we have to consider the environmental impact as well, right? Like your the overall CO2 quantification and all were discussed, right? Though through energy efficiency we can get some energy, but still you have some say, net CO2 emissions, right? Are you there?
Yes, ma'am. Yes, ma'am.
Yeah. Okay. So these were all the part of the lecture discussions of the week. Now let's go on to the practice assignment. So question number 1. The diameter of a die of an extruder producing extrudate of diameter 2.4 mm with a die swell ratio of 2 is, what is it? What is the diameter of the die? How do you calculate this? They have given that the extrudate diameter, the product coming out is having a diameter of 2.4 and the die swell ratio is 2. Now how do you find the diameter of the die?
Ma'am, is that die swell ratio is the ratio of extruded by diameter of the die?
Okay. So what do you get the value?
Is that true? Then the diameter of the die will be 1.2.
Okay. So what about Shiva? Do you agree with that? Yes. Okay. Shiva is also saying that, yeah, he agrees with that, and the answer is 1.2 mm. Yes, both of you are right. So die swell means obviously it is swelling. So that means the diameter of the die will be lesser and the extruded diameter will be larger, and obviously it is extruded diameter to the diameter of the die. So obviously you end up with the value of 1.2 mm. Okay. Question number 2. In twin screw extruder, dash screw helps in high pumping efficiency, while dash screws helps in high dispersion efficiency.
Ma'am, single screw helps in high pumping efficiency,
No,
while the
1 second. It both the cases it is a twin screw extruder only. I am seeing. Sorry. Some answer is being chat box. Okay, Shiva is saying co-current and counter-current. So, Udaya, you want to think for a while?
Ma'am, if the same if the two screws moves in rotates in same direction, then there will be high efficiency in pumping. While they move in opposite direction, there will be dispersion efficiency, ma'am.
That is what Shiva has also told. Yes, it is co-rotating and counter-rotating. Yes. So when there is a co-rotation, there will be high pumping efficiency. Okay, it can pump, better. Whereas, as you said, when it counter rotates, obviously, there will be a better mixing and better dispersion. So that is what is the answer. Okay. Now let's go on to third question. Stretching is a processing step in blow molding operation. Is it true or false? A stretching process involved
Yes,
in.
ma'am. True.
So what about Shiva? True. Okay. Why do you say true? And what are the steps involved? Do you remember?
Yes, ma'am.
Hmm.
The mold closes. The preform is formed. Preform or parison.
Okay.
Then it will be stretched for a thin layer
Okay.
to get a thin layer, and then the inert gas is blown into the mold,
Okay.
and the mold, the polymer melt will confirms the shape of the mold,
Yes.
and
Okay.
cooling process will take, and the mold opens and part is ejected.
Okay. Yes, you are almost right. There is one thing. Initially, the mold should be heated, right? Because the polymer should start becoming flexible, right? Otherwise, at room temperature, it might not be flexible. So, first you initially heat the mold and then put the preform. Okay. The heating process you missed, whereas you said the finishing cooling process. Okay. So, it is first mold heating and then mold closing and parison insertion, as you said. And then it is stretched and then air is blown so that the preform takes the shape of the mold, and then finally it is cooled and mold is open and the product is taken out. Okay. Yeah. Now let's go on to the next question. Arrange the processing operation of polymers in the increasing order of their cycle time. So rotational molding, thermoforming, injection molding, compression molding, blow molding.
First, injection molding will come first, ma'am.
Okay. So do you remember how
Then
many?
blow mold,
Okay.
ma'am.
Do you remember how long it takes? Approximate timings.
1 to 10 second, ma'am.
Okay. And then the second one.
Blow molding
Okay.
and thermoforming
Okay.
and compression and rotational molding.
Okay. So, Shivakumar, do you agree with the answer or you have a different answer? You're searching the document. Do you don't remember? Almost same. Okay, then what is the difference? You didn't say you also think the same, but it is almost same. That means there's a minor difference. What is it? If it is there, what or what do you so you agree with that? Okay. Now let's see what is the answer. As you said, injection molding, it takes 2 to 10 seconds, and then blow molding, 10 to 15 seconds it takes. Thermoforming, it takes about a minute. Compression molding 2 to 6 minutes, whereas rotational molding, it takes about 30 minutes. So these are all approximate timings. So these are the cycle time. Okay, so being this short, very short cycle time, to get the product, that is why this plastics or the polymers are extensively used compared to other operations, which takes very comparatively large quantity of time or long time. Okay. Okay. Dash is used for reduction of molar mass to achieve good flow behavior. What process is used?
Mastigation, ma'am.
So, Shivakumar, do you also agree? Yeah. Okay. Yes, it is mastication. So, molecular dynamics deals with solving of dash balance or balances. So, what are the things you will solve? Or, no, molecular dynamics deals with what?
Energy balance, ma'am.
Is it only energy balance?
And material balance.
You're saying energy and material balance. Okay. Is there anything else? Shivakumar is saying material and energy and momentum balance. So just read the method. It is molecular dynamics, right? That means it deals with microscopic or molecular level materials, right? It deals with the molecules, right? So in molecular dynamics, you will be dealing actually with momentum balance only, because again, if you remember your thermodynamics and all, at molecular level, it is only the momentum and the collision between the atoms or molecules that decides the temperature, right? So everything comes with the movement of the molecules, correct? So only momentum balance will be solved in case of molecular dynamics. Whereas when you take in continuum approach, continuum approach means it takes the whole system, larger system, macroscopic level behavior. That is why, you have averaged, properties like your averaged volume, and then you will deal with your volume fractions, in case of blends or anything, or you will have more of an averaged behavior, and there you will be solving your your material balance, your energy balance, and your momentum balance. That is where, in case of your material balance, you will have the conservation of mass, and especially specifically in case of incompressible fluid, you will be solving kind of different kind of equation, whereas compressible fluid density comes into factor and we will be solving different set of equation. And then in momentum balance, you will be solving your Navier-Stokes equation, and finally your energy balances, you will be solving. So there will be a combination of different balances, that is your transport phenomena comes into picture, whereas at your molecular level it is more of your momentum of atoms and molecules that decides everything. Okay. I mean, you can estimate every microstructural behavior, everything based on the atoms and molecules movement or momentum. Okay. Okay. Now let's go on to this. Divergence of velocity is zero for dash fluids. What type of fluids have the divergence of velocity zero? I almost told the answer while while saying the explanation for the previous question.
Incompressible fluids, ma'am.
Is it incompressible fluids? What about Shivkumar? Do you agree? You have said yes for, is it compressible? So one person is saying incompressible, another person is saying compressible. So which one is right? Okay. Let's see the answer. As you said, it is incompressible fluids. Okay. So what happens in case of incompressible fluids is that when you write the mass balance, so you write it in terms of the density. So here you assume some kind of a small volume element. For example, in rectangular coordinate, you will assume kind of a cube. Okay. And you will consider the cross section to be kind of constant. So how do you write the mass? It is, mass is nothing but density into volume, right? So your area is constant, so you can remove that. And since there is a conservation of mass, sorry, there's a conservation of mass, so mass is conserved, so the right hand side is 0. So what happens now? It will be a multiplication of density and velocity. Okay, so your unsteady density and variation of density with x, y, and z, and then variation of velocity with x, y, and z. This is what is your gradient of, sorry, divergence of velocity. So what happens in case of an incompressible fluid? So this density is constant, so this whole term vanishes off. So obviously you will end up with divergence of velocity to be 0. Okay, this you may be solving in your fluid mechanics or in your transport phenomena, definitely. Okay. Yeah, Shivakumar, you want to ask something? Shivakumar, you have just typed ma'am. Okay, you are saying okay, ma'am. Yeah. Okay. Now let's go to this next question. Identify the viscous dissipation term in the below equation. So this is the energy balance equation. So which one of the terms? It is having uh, rho c rho cp dot t by dot t plus rho into v dot gradient of t equal to k into del square t plus sigma grad v. Which one of these term is a viscous dissipation term?
Ma'am, sigma gradient V.
That is a viscous dissipation term, is it?
Yes, ma'am.
So what about Shivakumar? Do you also agree that is a viscous dissipation term? Okay. So what are the other terms? What about rho in rho v dot grad t term?
Ma'am, that kth is thermal conductivity constant, ma'am.
Yeah, that is okay. What is the whole term? If you have
Uh,
thermal conductivity, then
conduction.
yes, that is a conductive term. What about this term which I am pointing to? Rho into v dot grad t. First is unsteady state term. Okay. What about this term? There is one clue in the term with which you can find out what is that. It is actually convective term. You can identify with the velocity vector. Okay. During flow, it's actually the first term is your internal energy accumulation. Okay, it's correct. It's an unsteady state term. So the energy accumulates, or it becomes unsteady state because there is some energy accumulation, which can be a summation due to some convection, conduction, and viscous dissipation. Okay. Okay. Next question. Recycling polymeric materials in the same application is open loop recycling. Is it true or false?
False, ma'am.
Okay, what is it then?
It is closed loop recycling.
Okay. Does it have any other name? Does it have any other name? Closed loop recycling? Or what type of recycling does it come under among the major classification of recycling?
Primary recycling, ma'am.
Yes. Yes. So the answer is false, as you said. And so the recycling polymeric material in the same application is closed loop recycling. This is a primary recycling. Whereas, secondary recycling, it is for a different application, and case dependent, it can be either an upcycling or a downcycling process. When due to due to some other degradation or something, and due to the recycling process itself, if the properties are deteriorated and you get some low value products, then you will it is a downcycling. Whereas when you get a better high value products, then it is a upcycling. Okay. Yeah. Now the next question. Impact strength of PET dash after 3 cycles of recycling, while viscosity dash after 100 cycles for LDPE. What happens to impact strength of PET after 3 cycles, and what happens to viscosity uh, after 100 cycles for LDPE? Is there any?
Ma'am, the impact strength will reduce us, ma'am.
Okay. And what about
And
viscosity of?
viscosity
Of
will
L?
increase us for L.
Okay. So Shivakumar, do you agree? Okay. Now let's see the answer. As you said, impact strength decreases for PET, whereas the viscosity increases for LDPE after 100 cycles. So for three, what happens in case of PET after 3 cycles, there is a drastic reduction in molecular weight as well. So it drops down from 38,000 to 22,000, and the impact strength drops from 25 to 20 joule per meter. So this may be due to different kind of reasons. One of the major reasons, in fact, one of the major hurdles in recycling or upcycling or downcycling of PET, especially the upcycling of PET, is the contamination by acid producing contaminants like your polyvinyl acetate, which releases your acetic acid, and then your PVC, which releases your hydrochloric acid, right? And then in LDPE, so 100 cycles, it causes viscosity to increase from 2000 to 13,000 pascal seconds. So we can see that property, the values of properties may increase or decrease, but end of the day, what might happen is that it might not be, the material might not be suitable for that particular kind of application, right? So that forms the hurdle. And the approach is to see how to make it value adding in case of an upcycling process, or else you might end up with a downcycling, or finally you may end up with uh, disposing it as well. But in order to upcycle, you have to see how to really play with this with these changes, and have a beneficial you know uh, output. Okay. Okay. Now next, according to Winter Chambon criteria dash is independent of dash at the gel time. What is the winter Chambon
The modulus, the modulus is independent of the frequency, ma'am.
is it modulus independent of frequency?
Mm, that the ratio of uh, loss of modulus by storage modulus.
Okay. So Shivakumar, what do you say? Is it modulus or is it the ratio of loss modulus to storage modulus that is independent of frequency? Shiva, are you there? Okay, anyway. Response? Yes. It is tan delta, which is nothing but your ratio of loss modulus to storage modulus, which is independent of frequency. And that is what was shown, you know, in this plot. So because your g prime is also a function of omega and your g double prime, which is the loss modulus, is also a function of omega. And when you take the ratio, your omega cancels out and it becomes independent of frequency at the gel time. Okay. And this gel point is also called as a crossover point. When you see the loss modulus versus storage modulus, loss modulus and storage modulus versus time, you will see that there is a crossover after gelation, right? You remember the other plot as well, right?
Yes, ma'am.
Yeah. Okay. Okay. Let's go on to question number 12. Identify mechanical and chemical upcycling processes from the below. So you have to identify which one is mechanical upcycling and which one is chemical upcycling among the below processes. Post polymerization modification to improve processability. Is it a mechanical or a chemical upcycling? This is taken from your lecture only. Okay. What about use as a particulate reinforcement? Yes. Okay. Okay. Shivakumar, you have typed. So you are saying post polymerization modification to improve processability is a chemical modification, and uses a particulate reinforcement is a mechanical. Functionalization to improve compatibility of recycled blend is chemical, you are saying. And then chemicals with high value, you're saying again it is a chemical. And sorption and removal of volatile organic compounds also you're saying as chemical. So what about uh, Udaya? Do you agree with the answers?
Ma'am, I think absorption and removal of volatile organic compound is mechanical recycling.
Okay, okay. Now can we see the answers?
Yes, ma'am.
Yeah. So post polymerization modification to improve processability is a chemical upcycling, as both of you said. And then uses a particulate reinforcement. So using that polymer itself, the recycled, or sorry, that waste polymer itself as a particulate material for reinforcement into some other polymer base or polymer matrix as a filler. So that is a mechanical upcycling. Okay, because there is no reaction involved. It is just using it as a filler. Okay, functionalization, as the name suggests, so you're functionalizing some of the material to increase, improve the compatibility of recycled blend. So obviously functionalization, so you're chemically modifying the material, so it is a chemical upcycling. And then chemicals with high value, so you're trying to value add the material, that is again a chemical upcycling. And as you said, sorption and removal of volatile compounds is mechanical upcycling. Why this is mechanical upcycling? You are just doing some mechanical operations. I think you would have uh, mm, had this mechanical operation and mass transfer and all. So there is no actually reaction or anything involved. It is just some mechanical operation. You will just use some absorbing material or adsorbing material, right? So that is why it is a mechanical upcycling. Okay. Okay. Now the next question. Extent of reaction for cross-linking in step growth polymerization is directly proportional to average functionality. Is it true or false? So step growth polymerization, uh, where is it used actually? Do you remember one example where step growth polymerization is used?
Yes, ma'am.
So,
It is inversely proportional to the functionality, ma'am. Average functionality.
okay, okay. So where is the step growth polymerization used?
The acid and alcohol group.
Yes, yes, like in your PET making and all. Okay, so as you said, the extent of reaction for cross-linking, it is inversely proportional to the average functionality. So the statement is a false statement. Okay, so you had this. So for a monomer mixture with average functionality Fm, you have the extent of reaction given by 2 by Fm into 1 minus 1 by N. So it is inversely proportional. So more the functionality, then extent of cross-linking reaction is lesser, because with the minimum cross-linking itself you will form the complete 3D network, right? Yeah, Shiva has also said false for the statement. You're right, Shiva. Okay. Now, in chemolysis conversion of PET, in chemolysis conversion of PET, use of methanol leads to production of ethylene glycol and so chemolysis where the polymer is converted to its monomer. So methanol leads to
Dimethyl terephthalate, ma'am.
so what about Shiva? Do you agree? Okay. Yes. So chemolysis using methanol it forms dimethyl terephthalate. Whereas in case if water is used, then it will form terephthalic acid itself. It is the same monomer with which PET is formed, right? Whereas glycolysis leads to different set of monomers. Again, you will get ethylene glycol, but the terephthalate group will be different. Okay. Yeah. So that's all with the questions. So you have any other doubt? Thank you, Shiva. Thank you. Wish you the same. Happy Dashara to both of you.
Thank you, ma'am.
So you have any other questions, Udaya? That TG, I mean glass transition question, I'll answer you by next week. Uh, is there any other question you have for this week's content?
No, ma'am.
You don't have any question. Okay.
But I want to know one thing, ma'am.
Yeah, yeah, yeah. Tell me.
Ma'am, is there any app to know the recent advancement of the polymeric material and the problems with industrial with polymer, ma'am?
See, there is no particular app and all, but if you just go through these, lot of papers, you can go through the recent papers, and then so those things will really help you. When you search in Google Scholar and all, no, you will go through the recent papers and all. You can sort it by year and all. Okay, so that you will get to know the recent advancements and all. So there are different journals which are working on these. Okay, and you can attend conferences on polymers. So those journal, uh, again, these journal publications and all, you can see their uh, initial introduction pages and all, you can see where they might give some briefing of what is the current status and everything. And one more thing is that when you go through these papers or journals, when you go through the review papers, uh, if you give a term like a review of recent advancement in polymers, if you give a Google search and all, some review papers on polymers will come in different years. So those review papers, it will have collection of different things that has happened in polymers. They will discuss what are the things that had happened over the years, and you know uh, what are the challenges involved in that, and what kind of improvement can be done, right? Or what are the current research that is going on, all those, the gaps, everything, you will have detailed analysis. So when you go through the review papers, okay, the review papers will give you a good idea of current trends in lot of things. And mainly, you can understand through these journals and all. And normal Google search itself, if you just give, you will get some, at least some review papers. So you can take the keywords from those topic and go into further proper streamlined searches, like in your